Hi class, today we have the 11th lesson for vectors, but this class is about dot products. Yeah, mind you, all the vectors that we have been using, I and J, they are two-dimensional. They are two-dimensional vectors. For three-dimensional vectors, you have IJK. Yeah, IJ, of course, it has only this one. This is I, then this is J. Yeah, but if we have three-dimensional, then we have IJK. Okay, so how do we find the dot product of two vectors? The first one, we are given A to be 2I minus 3J, and B, vector B is minus 3I plus 1J. Then we want to find A dot B, dot product. Not just a product, this one is a dot product. So we say vector A dot vector B. So what is A? A is given as 2I minus 3J, yeah, dotted with what? Minus 3I plus 1J. Okay. So the thing here is you can solve the problem as we do in algebra. For example, if we have 2x minus 3 multiplied by x plus 4, we can say 2x by this, 2x squared, this by this is 8x, this by this is minus 3x, this by this is minus 12. So 2x squared minus 12 here, then here is plus 5x. We can also do the same as we usually do here. For example, we can say 2I times this one multiplies everything here. Yes, 2I dot minus 3I. But the thing is that, um, let me give you this 3 here, these two. I dot I is equal to 1. J dot J is equal to 1. They are unit vectors, 1. So I dot J is equal to 0. So note this one. I dot J is equal to 0. J dot I is what? So don't forget I dot J is 0. I is 1, J is 1. So if we say 2I dot this one, 2 times minus 3, minus 6. I dot I is 1. Do not forget. Now 2I with this one. 2 times 1 is 2 plus 2. I dot J is what? Is 0. Now we use minus 3 to multiply this. Minus 3I dot minus 3I. Minus 3 times minus 3 is plus 9. J dot I is what? Is 0. Do not forget. Minus 3I dot 1I. Minus 3 times 1 is minus 3. J dot J, not I, I'm sorry. J dot J is 1. So we find out that this term is 0. It vanishes. This is 0. It disappears. So we are left with minus 6 minus 3, which is minus 9. So all what I have done is just a waste of time. When you are dotting vectors, when you are dotting vectors, your concern should be what? The I, J and J. Do not bother to say after going through 2I and minus 3I, you go again 2I and J. You know it's going to give you 0. So whenever we are dotting two vectors, our concern is the corresponding only, just like we do in multiplying conjugate sorts, the first and the first, the second and the second. So in other words, so we wouldn't have gone through all this. We would have just said what? 2I dot minus 3I. 2 times minus 3 minus 6. I times I dot I is 1. You don't even need to write that one again. You don't even need to write it because it will not appear. So again, this j and this j, minus 3 times 1 minus 3. J dot j is 1. You don't need to write it, so you get minus 9. So it's going to be like just 2 lines. But I decided to do it this way so you know why we just have it like this in a very simple way. So the second one, I will not do it in that long method again, long way. So the second one is we are given vector m and vector n. Then we want to find m dot n. Vector m dot vector n. M is what? 2 minus 1 dotted with what? N is 3 minus 2. Please do not underrate the dot. If there is no dot, it means something else. If there is no dot, it means something else. Let there be a dot. Do not forget. So as I said here, your concern should be the I and I only, J and J only. So this one, 2 times 3 is 6. We use plus all the time. Minus 1 times minus 2 is what? Is plus. Minus 1 times minus 2 is plus 2. So this is 8. Then finally, what to take home is that the dot product of two vectors will not give us a vector. It will give us a scalar. Besides, this dot product is precisely called the scalar product. Why? Because once you dot the two vectors, the result is going to be an ordinary number. It's going to be a scalar. So dot product, we sometimes call it what? The scalar product. All right. So thank you for watching. Don't forget to follow, like, share, and comment. See my next video.